Okay, Assalamualaikum and hi all. So we continue our chapter 1 with engineered system for water purification. Okay, this is actually in your textbook is a chapter 4. Okay, so in previous lecture note have covered until chapter 3 in your textbook. So previously it was natural water purification. Okay, but starting this week, okay, I will cover on the engineered system. Okay, so this part, this chapter or subchapter also I will divide into a few parts. Okay, right. So since this engineered what system for water purification is a huge topic, so I will cover this part within at least 3 parts. Oh, sorry, 4 parts. Okay. So the first part, which is in this video, will cover on water treatment process, aeration, and solid separation. But in solid separation is a huge topic as well, so I will divide into part 2. Okay, right. Okay, so groundwater versus surface water. So this is the criteria of the groundwater, whereas this is the criteria of the surface water. Okay, so groundwater, the one that normally you have drink it, such as in the mineral water. So normally it's from the groundwater. Whereas for surface water, the water that being used to deliver to your house or to any premises for us to use. Okay, and then this is water treatment process treating of hard groundwater before we can start to consume it. So there are a few processes involved, which are aeration, okay, softening, filtration, disinfection, and finally storage, and then we go to the distribution system. So softening because we want to remove calcium and also magnesium content. Okay, and then filtration to remove calcium chloride and also magnesium hydroxide. Okay, so this is actually for water treatment process treating turbid surface water. This is what the process involved in order to deliver water to your house. Okay, so those problem with shabas, okay, they are actually using this kind of processes. It is a standard process that all those wastewater treatment industry using. Okay, so like shabas, and then in Pahang we have jaib. Okay, so it will involve pre-sedimentation, and then it's more complicated process, okay, to treat the surface water compared to the to treat the hard groundwater. Okay, so we will have those pre-sedimentation to remove larger suspended solid. Okay, this one later you will see that it will sludge will be removed. So this is number 1. And then second part will be mixing, flocculation, and settling. This where most of impurities, okay, will be removed by coagulation and also settling process. Okay, so this will use alum and polymers, BAC. Okay, and then this also will produce sludge that later will be removed. Okay, and then after that we go to the filtration, where we use chlorine. So the backwash water will be decanted, sludge will be dewatered and removed. Okay, so this is the part of filtration. And then we will have also adsorption, activated carbon, okay, for water that contains dissolved organic. Okay, and then finally we go to the disinfection to remove pathogens so that your water is safe to drink. Okay, and then we go to the storage to provide contact time for disinfection. So later on then it will go to the distribution system. Okay, so this is the general water treatment process to treat turbid surface water, right? Okay, so we go to the first process, which is aeration. So you see here in the groundwater, we have aeration. So why is it aeration is important? It is to remove undesirable gases dissolved in water. So meaning degasification. Because our groundwater contain carbon dioxide, it is a corrosive water, and also sometimes contain hydrogen sulfide. Okay, so when contact with oxygen, okay, because aeration, you put air in it that contains oxygen, iron and manganese oxidize to higher valence, okay, forming new insoluble complexes. So we use cascade tower or tray tower. So this is example of fountains, and then cascade aerator, right? And then we go to the solid. So the next process is solid separation. Okay, so here we can see sedimentation is the separation of unstable and destabilized suspended solid. Okay, the application in water treatment is to settle the coagulated and flocculated water. So when you use coagulation, flocculating, it will have flux. Okay, so this sedimentation is important to settle those coagulated and also flux, to settle down this coagulant. Okay, and then settling of treated water in iron and manganese removal plant. Okay, so the velocity of the flowing water is reduced so that the suspended matter can settle out, okay, under the influence of gravity. It cannot be so fast, okay. Okay, these are the factors affecting settling velocity of particle. So it is specific gravity of particles, flow velocity of water, temperature of water, shape, agglomeration, and concentration of particles. Okay, so sedimentation. Okay, discrete particles, and then flocculating particles, dilute suspension, concentrated suspension. I think this one you can read by your own, okay, and refer to the textbook as well. Right. So in a sedimentation, there are 4 types of sedimentation. Okay, the first one, which is type 1, is discrete particle settling. So later you will see. Okay, so for example, if we have like experimental apparatus, so we have the cylinder like this, and then you put water, let's say river water sample in this one, so you will see. So this is the type 1. Okay, let me show you some. Right, so you will see that there are 4 different, so there are 4 different types of settling. So the first one is discrete settling region, and then second flocculant settling region type 2, and the third part is hindered zone. Okay, and then the fourth type is compression zone. So the top one is the clear water region. Okay, so back to here. So type 1 discrete particle settling is actually particles settled individually without interaction with neighboring particles. And then type 2 flocculant causes the particles to increase in mass and settle at a faster rate. So and then the third type is the mass of particle tends to settle as a unit with individual particles remaining in fixed position with respect to each other. Finally, compression, the concentration of particle is so high, okay, because the downward it goes, it become more concentrated, okay. And then that sedimentation can only occur through compaction of the structure. Okay, so we refer to here, so towards downwards, okay, so it becomes the concentration of the impurities or any meaning that any impurities and also pollutant will be higher downwards of the cylinder, right? So we go one by one. First, we go to how to treat this every type of the particles, okay, of the settling. Okay, so we go to the type 1, okay, which is discrete particles in dilute suspension. Okay, it is characterized by particle that settle at constant settling velocity, okay, as individual and not flocculate. So two force on it, which is gravity and also buoyant force. Okay, so what is gravity force is described by this equation. Okay, this you may refer to your textbook, right? This is described in page 114. Okay, so all this is in page 114. Okay, and then the second force acting on it is buoyant force. So imagine this is your particulate or your impurities. Okay, so you can see this is your FD. This is, oh, sorry, must be one of it is FG. Okay, this is buoyant force FB, right? So another one is, this is FG. Okay, the gravity force. Okay, FD is the drag force lah. Okay, if you see here is drag force. Okay, so this is FB is your buoyant force. And then we go to the terminal setting velocity, which is described by this equation. Okay, so we know that from you study from your previous courses like fluid mechanics. Okay, so you know that laminar flow, this is the formula to describe laminar flow, transitional flow, and turbulent flow, where we use Reynolds number as described by this equation. Okay, so later on you will see that the importance of determining the terminal velocity is by solving this equation, where rho p is actually your density of the particle and rho w is actually the density of your water. Okay, this is the viscosity of your water or any liquids that the particles in it, right? So d is actually the diameter of your particles. Okay. Okay, now we discuss on example 4.1. Okay, find the terminal settling velocity Vt with diameter of 0.5 with specific gravity of 2.65. So we use this formula. Okay, so how do we determine the density of particle? So given in the question is Sg. Okay, oops, sorry. So I need to change it to the pen first. Okay, so given Sg, okay, is equals to what is it, 2.65. Okay, so this one will be equals to particles or object, okay, over density of water. Okay, so you will know the rho p, okay, meaning that rho p is equals to 2.65 times density of water is 998.2. Okay, so that's why you will get like in your textbook is 2650. Okay, 2650. So the density of water is 998.2 and then mu is 1.002. This one you can find it from the appendix. Okay, right, so then you solve for Vt, you will get Vt is equals to 0.22. Okay, so check the Reynolds number. Okay, how are you going to check the Reynolds number? So you use as normal Reynolds number formula, which is Re equals to rho ud over mu. So you have your density, your density of water. Okay, this is density of your water, and then the terminal velocity. This is actually your Vt just now, and then d, the particle diameter. So this is the viscosity. Okay, that's why you need to get this one first, then only you can determine your Reynolds number. So by substituting the value of Vt, you will get 112. Okay, so repeat the step and then finally you get this value. Alright, so for the settling column, this is another function of it. So I think I will continue this part on the part 2 of this lecture. Okay, thank you. See you in the next part.